Okay, a short lecture now on the heterogeneous cooperative cluster sizes. And what you see here in the picture, we just wanted to say what happens if we have sometimes clusters of size 3, sometimes of size 7, and even one that is not cooperating. And we compare this with the broadcast phase where we don't have any cooperation. So the results I show you here, sometimes hard to understand so quickly, but I try to guide you through there and to show that also in these kind of scenarios we can expect a gain, because most people assume that if one guy in the cell would not cooperate, will he not destroy the gain for the others? Okay, if I say such a cluster of 7, it could be fully meshed, right? Or it could be also sparsely meshed. This has an impact, of course, because then you would have more transmissions and you would pay more energy for that. So here we looked into a single cloud, and we could just look into the right figure here, which is the end result. But what I would like to start with is to look into the packets sent by the base station for certain situations. One is pure broadcast. Then there are 3 of no, there's one pure coding. Broadcast was uncoded. Pure coding is coded version of it. And then you have uncoded cooperation with different size of the heads. So here I only have 1 head, 3 heads, all heads. Here we have the same, but with a cooperation and coding, 1, 3, and all heads. And we look just at the number of packets that were sent from the base station. And you will see that broadcast, they have to send a lot, especially if this size of a group, and we have only a single cloud. If you have 32 devices in a cloud, you see, there's a lot of packets it has to send. If you code, it already goes down, and the more you have, of course, the more you have to send. Remember what we said before, we have to see the worst guy, and then there's always somebody that it can be worse than me. And then we say cooperation with 1 head, then we only listen to this one device. It doesn't matter in which group size you are. You look at this specific device and you make him happy until it starts. If you have 3 heads, you see there's a difference between the first 3. And when you have 2 heads, if you have 3 heads, in this case, when you have a group size of 2, of course, there are only 2 heads. You see that once you reach the number 3, which is smaller than the group size, it will be stabilized, right? But even if you put everybody 2 heads, you see there is a minimum in that. And this is what you said, the base station will only send 1 packet, which is nearly optimal. So if you do cooperation, then if you have 1 cluster head, you have errors on the link, so that if you pay. If you have more heads, then you can bring these devices down. And this amount of packets that you send has also an impact of the energy, of course, right? And not only from the network perspective, but also for the cluster. Here we only look at the individual device. And these are the packets received from the cellular link. So this is what is sent, and this is packets are received. So what you see is in the broadcast, what you send is also what you receive. The same for the pure coding, but for the others it's different. Why is this? Because if you say that I only have 1 head, the others are, so to speak, idle. They're not receiving anything. So the ratio goes down, as you can see, for 1 cluster head or 3. If all cluster heads are receiving something, it's exactly the same what you receive and what you send, right? And for coding, you see also the same, but you see there seems to be a little bit difference between the strategies, whether you're coding or uncoding here in the cooperation. Good. But once you receive them, you also have to send them on the short range, right? And there's a big difference. So what you see here is we only look at now not at broadcast and pure coding because they don't do anything on the short range, but you see there's a difference how much they will sending out depending on the cloud size, but also on the strategy. And strategy, I mean how many cluster heads are there. If you had a lot of cluster heads listening in, what you have here and here, you had to receive a lot of packets. But this means you don't have to send out so much anymore to make them happy. And here you see the corporation will have a little bit less than this one, but this is not so important. Interesting is then the receiving part. And here you see that also here it makes a difference how many cluster heads have been listened in beforehand, but also whether you code or not code anymore. And here you see the uncoded guys in the receiving phase, they have to receive a lot of more packets than the coding guys. And this is because they have to deal with duplicates. The coding cuts out the duplicates. And this you will see on the short range receiving part. And if you put all of that together in the way we did it also before in our analytical framework, you come up with the overall energy. And then you look, what is the best energy I could get here, right? So, for example, if you go up with the heads, you will grow up. And for when you have uncoded all heads, you see there's an optimal number, right? And then here in the coding, it does not matter. Here you say the more cooperating devices I have, the better it is. Good, this was a single cloud, right? And if I have multiple of these clouds, then in the same cell, and they're cooperating, you will also see some difference here. In all, what you can see is that cooperation pays off. If you give them a little bit of coding there, even there you can gain. Don't let all the devices listen in, right? Because this is not so good for higher cloud sizes. Then it's better to give one or three cloud sets. I think that is more than enough. Good. And now is the kind of heterogeneous clouds. So question is, what happens if I have smaller and bigger clouds? And now beforehand, when we had homogeneous clouds, we always had clouds of size 1, 2, 4, 8, 16, and 32. In this setup, what we see here is to say we have one group with 1, one group with 2, one group with 4, one group with 8, one group with 16, and one group with 32. Sorry. And if you then look at the overall, I don't go to individual. If you want to add as reference, you have it there. Then you see that the best you can do is maybe one cluster head for all of them. I think that's the best that you can get compared to the others, right? It's enough. So you don't need so many to do that. And this corresponds to the picture I draw you before in the football stadium, where the seating was there, and we said, okay, where to put really this stream and how many cluster heads we need for that. Good. So you see here the winner, right? I just picked it out. Okay, now one last topic to make it realistic, and this is mobility.